Okay, now this is the very last example in section 4.1, and it is finding zeros when you have a quadratic type of form. So most people actually, whenever I give them this problem, they don't even notice it's x to the fourth, x squared. They automatically look at this and go, this is just x squared, x 45. And that's actually really on the right track. So those people actually get credit. That's why this is going to be so hard for me, because I'm really used to giving partial credit. So now I don't know how I'm going to give y'all partial credit. So we're going to have to figure that out. But this is actually really on the right track, because a quadratic type means it's of the form a something squared plus b times that something plus c. Okay, and it's just like a quadratic. So what do? Well, in the first video that I did, I started on this handout, but I skipped this part because we did this part in class. But this handout has on the top the steps for solving a quadratic type of equation. What we're going to do is go all the way to here. Okay, we're going to go all the way to there. And we're actually no, we're going to do the whole thing. Yeah, okay. Anyways, so what we're going to do is we're going to find that bx term. We're going to let u be that variable, okay? We're going to square both sides of that equation to double check that u squared is the variable in our ax squared term. We're going to rewrite the original equation. Then we're going to solve that equation by either factoring the quadratic formula, etc. And since we just solved it for u, we now need to replace u with whatever we said u was back in step 1. Okay, so you can pause this, screenshot it, download the handout, whatever you want to do. But I'm going to take this away, and we are going to solve this problem. So I'm going to switch to just a regular pen. So what I'm going to do is I'm going to do step 1. I look at my original equation and I see 4x squared. So my bx term is 4x squared. So what does that mean? That means that I'm going to say u equals x squared. I'm ignoring the 4. Okay, that's my b. My step 2 is to square both sides. Well, u squared, x squared squared. So I'm going to square both sides. And what do I get? I get u squared equals x to the x squared squared. 2 times 2 is 4. In my third step, I'm checking, right? I have that as a whole nother step. I'm actually going to scoot that forward because I always combine steps. So step 3 is to check that is my ax squared term. Well, my leading term is x to the fourth. So my leading term is x to the fourth, just like u squared? Yes. Okay, so now I can continue with step 4. Step 4 is to rewrite the original equation. So my original equation is f of x equals x to the fourth plus 4x squared minus 45. Well, instead of x's, I want to use u's. So I'm going to rewrite this as, instead of x to the fourth is u squared. So x to the fourth gets replaced by u squared. What's x squared? That was u. Right, so here's my 2 important replacements. Those are my 2 important substitutions. So I replace that. Now, what I want to do next is I want to factor or use the quadratic formula or whatever. Actually, since I don't have an equal 0, I just have like a y equals, I can't use the quadratic formula. So I'm going to go ahead and factor this. How do you factor this? U and u. What's 45? 45 is 15 times 3, right? Think of a clock, 15 minutes, 3 times 45 minutes. 45 is 9 times, I've not been out of school that long, 9 times 5. Oh goodness. 9 times 5, and I'm sure there might be another one, but that's good enough for me. Actually, no, I think it's just 45 times 1. So we have 15 times 3. That's not going to work because our center term is 4. 9 times 5, that's going to work perfect. Plus 9 minus 5. So then instead of u's, I need to replace, what is u equal? X squared. So this is going to turn into, instead of u, it's x squared plus 9, x squared minus 5. So my function, f of x, is x squared plus 9 times x squared minus 5. Now it's factored. Yay! Now that is, sorry about that. I want to cross my legs and sit different. So that's just the factored form. That was step 1. If we're trying to find zeros, we need to factor it. That's just step 1, factor. So now we have it factored. And what do? You set each factor equal to 0. X squared plus 9, x squared minus 5. So we're going to set each factor equal to 0. I'm going to scoot this page up, and I'm going to scoot my body back. So we set each factor equal to 9. X squared plus 9 equals 0. X squared minus 5 equals 0. And I solve. So minus 9 minus 9. Square root both sides. And I know that I, the negative sign, needs to come out to be an I. And the square root of 9 is 3. So I get x equals positive 3i, negative 3i. I get 2 complex zeros from this factor. Then add 5, add 5. X squared equals 5. Take the square root of both sides. I get x equals positive root 5 and x equals negative root 5. So I get 2 irrational, but they're still real zeros. So 2 real zeros from this one. Okay, so now if I was going to graph it, when I graph it, I only get, I know it's an x to the 4th term, so it's a positive x to the 4th, so it's going to go up on one side, up on the other side. The square root of 5 is 2 point something, 5 square root, 2.236, so square root of 5 is about 2.236, there we go. So I'm going to go over 1, 2, 1, 2, positive 2, a little bit, negative 2, a little bit. And since those are both to the first power, those factors are, it's going to cross through at those. Now, since you have 2 complex zeros, the 2 complex zeros are what's going to cause that little wiggle, okay? So your function is going to look like, okay? See, I told you, they never line up. This is the negative square root of 5, this is the positive square root of 5, and this little wiggle is caused because of these 2 complex zeros. You don't always have wiggles from complex zeros, but sometimes you do. Okay, that's all I wanted to say on that, but this problem was a lot harder and more involved. Now you might be asking, how do you know it crosses through? There's a square. Isn't that multiplicity 2? And I'm going to remind you that no, it's not. The multiplicity is found outside the factor. If I were to rewrite this whole function, let me grab a different color. If I were to rewrite this whole function in its linear factors, it would look like this. X minus 3i, x plus 3i, x minus the square root of 5, x plus the square root of 5. That's what it would look like. And each one of those has a power of 1. Okay, each one of those is x minus 3 to the 1, x plus 3i to the 1, to the 1, to the 1. So they all have multiplicity of 1. So you can think about that. How do you get those factors? Given these. So you can get those factors just from these right here. So that is all of 4.1 that I have. I think I'm going to make up some kind of questions. Actually, no, I think there's some good questions on my math lab that I'm going to try to find and post. Okay, good luck. Let me know if you have any questions.